Hello, welcome back to my channel, and in this video we are finally gonna start solving some of the problem question and try to get some exercise in solving problems in quantum mechanics. And this is one of the problem where you have this Gaussian distribution and where you have this a big A, small a, and this lambda are positive real constant, and you need to determine what this a is, what is the expectation value of x square is, and then we're gonna calculate our variance, and then standard deviation, and then we're gonna sketch the graph of this Gaussian distribution after finding all the variables. This is not a quantum mechanics question. This is more of a probability question, how to do things. But if I put here, instead of giving you this Gaussian distribution, they could give you like wave function. But remember to square the wave function, because squaring the wave function gives you the probability density function. In this case, I'm giving you the probability density function, not the wave function. So in this case, we don't square it. Okay, if people give you the wave function, then you square it. So okay, so the first question should be pretty easy. Determine a. This is the normalization constant, and we know our probability density function must be sum up to this 1, and using this condition we can find this a, and you can plug that or your the distribution we have, this Gaussian distribution, and then we try to integrate. And in this case we can use our substitution, where you substitute u, which is x minus a, and d, which become d, u become dx, and limit remain the same. Now you have this Gaussian integral and this exponential to power this minus lambda u square, and these integrals are very popular, and you can find it any textbook and all those things how to solve this. If you want me to solve it for you, let me know. I can make a video based on that. But these are pretty much very famous integrals, and you can find the exact answers. And in this case we have this exact answers where we find this and this answer is square root of pi over this lambda. And now we can get our a, and a become square root of lambda over pi, and we found our normalizing factors that will help us to normalize our wave function. We found our a. Now we want to find out the expectation value of x, expectation value of x square, and this sigma. So expectation value of x, we have learned the definition, and now we can you have your x, you multiply with your probability density function, and then you try to and integrate between negative infinity to plus infinity. I just plugged in the a here. We already find out the a. We don't want to complicate the expression, so you can leave it as a here and then plug it in the end. And now do the same thing. We have you're gonna do the substitution of x u as equal to x minus a, then this will become such an integral, and then you can separate them into two integrals. And whenever you have from minus x to plus x, you always can check if it's an odd integral or an even, and then if it's an odd, this become to 0, and this is an odd integral, so this becomes 0. The first expression goes to 0, and this is, we learned in a previous video what this Gaussian integral is. Then we can substitute that, and you get the expected value of x is a. Yeah, now we're gonna do the same thing when you want to calculate the expectation value of x square, and you have all those things, and again the second integral cancelled out because it's an odd integral, and second integral goes to 0. The first integral is also a very well-known function, and you can find it online. This is equal to this expression you get, and the third one we already knew how to do it, and you get the expectation value of x square is this a square plus 1 over 2 lambda. And now we want to find the sigma, which is the expression of this expectation value of x square minus the mean square, and you substitute all the expression and you get the sigma square is 1 over lambda, 1 over 2 lambda, and then you can find the lambda is equal to 1 over square root of 2 lambda. So now you have all the expression. Now you can play with it, and you can use Python or any kind of plotting tool to plot the function. Yeah, in this case, I chose x to be 2. You can choose anything else. And so I hope you like this video. This was a very easy and very general question that you should know how to do it in if you're learning quantum mechanics. So I hope you like this video. If you do, give it a thumbs up, and I will see you next time.